Thank you for completing the Collaborate board. What do you notice? What do you wonder? I'm going to go over some things that I notice about these two diagrams. Let's see, in the first one I notice that we have an angle whose vertex is on the circle. Right? Here's the angle, so if I follow the angle out to the circle, I see that that green arc is the intercepted arc for that angle. I also notice that that arc is 60 degrees and the angle is 30 degrees. Well, that seems like that arc is twice as big as the angle. So I could write that down as the intercepted arc is twice the measure of the inscribed angle. Anything that's inscribed, by the way, that just means that it has the vertex or vertices, if it has more than one vertex, on the circle. That's all inscribed means. I have another diagram over here. Right? I see I've got a diameter drawn, right? So diameter is diameter AB there. And we know a diameter divides a circle in half, so that green arc is going to be 180 degrees. If I go to the endpoints of that arc and follow it back to the angle, I see that angle measures 90 degrees. So I have an intercepted arc that's 180 degrees, and the inscribed angle is only 90 degrees. Well, it seems that the inscribed angle, so if I take 180 and divide by 2, that would be 90. So the inscribed angle is half. The measure of the intercepted arc. And I think with what I've noticed, I think we may have discovered the relationship between an intercepted arc and the inscribed angle and the intercepted arc. So the intercepted arc is twice the measure of the inscribed angle. The inscribed angle is half the measure of the intercepted arc. And I believe this next page is in your notes as soon as it decides it wants to change the page. It's thinking about it, yes. And this is in your notes. So you have this definition, and I think that the diagram needs to be added. Or the words that go, looks like it's the words that go with the diagram. So an inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of the circle. Just as a reminder, you don't have to write this part down, but just as a reminder, for central angles, the sides of the angle were the radii of the circle. So an intercepted arc consists of endpoints that lie on the sides of an inscribed angle and all the points on the circle between them. All right, so we're going to add some information for this diagram, and I'm just grabbing out your notes to double check and see what your notes has. All right, so you have the information in your notes. You do not have the diagram. Yeah, you don't have this diagram at all. So if you have space, you can add this. I'll make this optional. All right, so here we have angle DEF is the inscribed angle, and then arc DF, which is between the angle. So right here, if we follow the sides of the angle, notice that that arc is between the sides of the angle. So angle DEF is the inscribed angle because it has the vertex on the circle. Its sides are formed by chords. And DF is the intercepted arc. It's where the chords intersect the circle. Okay? So point E is the vertex. And then here's the intercepted arc. And these are chords. Okay. So this is what our inscribed angle looks like. Right? So you need to be able to recognize that when an angle has the vertex on the circle, that it's an inscribed angle, and there's a relationship between the inscribed angle and the intercepted arc. And we're going to write that. You have, I think, the next page in your, not this page, the page after this in your notes. Here we're just going to look at what's an inscribed angle and what's not an inscribed angle. So an inscribed angle is an angle whose vertex lies on the circle and whose sides are the chords of the circle. We also can have a chord and a tangent. I'll show you what that looks like in a moment. So here, angle ABC is an inscribed angle, right? So it has the vertex on the circle and the sides, BC and BA, are chords to circle O. So in our first example below here, angle 1 here is not a central angle. And the reason is that the vertex is not on the circle. It's in the middle of the circle. That's at nothing. That's just an angle. Number 2 is an inscribed angle because the vertex is on the circle. Number 3 is not an inscribed angle. This is a central angle because the vertex is at the center of the circle. Right? And number 4 is also not, number 4 is also an inscribed angle. So 2 and 4 were inscribed angles. The vertex is on the circle. Number 1 and 3 are not inscribed angles. And here goes our page. Any moment now. Right? So you have this in your notes. You have the words. So an intercepted arc is an angle that intercepts. So an angle intercepts an arc if and only if, number 1, the endpoints of the circle lie on the angle. And you have that in your notes already. All points of the arc except the endpoints are in the interior of the angle. So notice here, the intercepted arc is between the angle except for those endpoints which lie on the angle. And each side of the angle contains an endpoint of the arc. I do want you to write the relationship between the arc and the angle and the arc. So the inscribed angle is, I'm going to write this a little bit nicer. And you have it as a blank to fill in, so you already have this part written in. Inscribed angle equals, and then you're going to fill in the blank. It's just not possible, I think, in this center of the board to make a straight line, unless I use a line tool. So the inscribed angle equals half the intercepted arc. I'll try to write nice and neat so you can read it. You can also think of it this way, that the arc equals 2 times the angle. Right? So you can put both of those in there. Because sometimes it's going to be easier to use the formula inscribed angle equals half the intercepted arc. So if we're solving for the angle, it's going to be easier to use that equation. If we're looking for the arc, it's going to be easier to set up the equation as arc equals twice the angle. So if the inscribed angle is half the arc, then the arc must be twice the angle. Here we have a picture, all right, and what that looks like. So the inscribed angle has the vertex on the circle. The sides are chords. And the intercepted arc lies in between the angle. Right, so now we're going to solve some problems. I think that's the next thing coming up. Oh, that's right. I want to show you what, I don't have this in your notes, but I did want to go through, and I have the same thing as on the other page. Inscribed angle equals half the intercepted arc. 2 inscribed angles equals the arc, or the arc is 2 times the angle. All right, so here's any one. So our inscribed angle and the intercepted arc could look like any one of these. In all cases, though, if the vertex is on the circle, then the angle is always going to be half the arc, or the arc is always going to be twice the angle. So here we have an example. In the case 1 here, BC is a diameter of a circle, and AB is just a chord. Now remember that the diameter is the largest chord in a circle, so this is still 2 chords creating the inscribed angle. It just happens to be that one of those chords is the diameter. Here we have case 2. Case 2 and case 3 really aren't much different. In one case, the center of the circle is in the interior of the inscribed angle. In one, it's not. Doesn't really matter. Either way, this angle is formed by 2 chords. The vertex is right here at right on the circle. I'll add it to this one too. Right? And in all cases, the inscribed angle is half the arc. The arc is twice the inscribed angle. Here's our last way that this can look, and let's call this case 4. And we're not going to be dealing with this case in this lesson, but we will in a later lesson. All right, so again, we have the vertex on the circle. In this case, we have one side is formed by a chord. The other side is formed by a tangent. It doesn't matter that one side is formed by a tangent. Since the vertex is on the circle, the angle will still be half the arc. So if we take 2 times the angle, we'll have the arc. Now the tricky thing on this one, I think, is that where the arc is located. So instead of going between the 2 endpoints of the circle, it goes from vertex to endpoint. All right, so this right here is the angle. I'm going to change colors. So here is the angle, the inscribed angle, and here is the intercepted arc. We'll look at this case in a later lesson, but it's still solved the exact same way. Sometimes they're called tangent chord angles. They're still a type of inscribed angle because the vertex is on the circle. And Now that we've gone over all our relationships and what the inscribed angle looks like, now we can solve some problems. Now I think I'm going to split this video into two videos. So in the next video, we're just going to be solving problems with inscribed angles and the intercepted arcs. So join me in that video. So bye for now.
Oh,